Hello everyone, welcome back to my YouTube channel. I am Vaishnavi from Sri Venkateshwara College of Engineering, Department of CSE. Today in this video, I will be discussing about normal form in SQL. Introduction to normal form in SQL. Normal forms in SQL are guidelines for organizing relational databases, minimize redundancy and improve data integrity. The goal of normalizing a database is to reduce data redundancy and ensure data consistency. There are different levels of normal forms, with each level building up upon the rules of the previous one. First normal form, 1NF. In 1NF, each column in a table must contain atomic values, meaning each value is indivisible. Duplicate columns are not allowed in a table that is in 1NF. Tables in 1NF are flat and do not contain repeating groups. Second normal form, 2NF. To achieve 2NF, a table must be in 1NF and all non-key attributes must be fully functionally dependent on primary key. This means that each non-key attribute must depend on an entire primary key, not just a part of it. 2NF helps in eliminating partial dependencies and improves database consistency. Third form, 3NF. 3NF builds upon 2NF by ensuring that there are no transitive dependencies in the table. A transitive dependencies occurs when a non-key attribute is functionally dependent on other non-key attribute. By eliminating transitive dependencies, 3NF reduces data redundancy and improves the data integrity. Boycott normal form, BNCF. BNCNF is a striker form of normalization that addresses certain anomalies that can occur in 3NF. A table is in BCNF if for every non-trivial functional dependencies X implies Y and X must be a superkey. BCNF is considered the highest normal form for practical purposes in SQL databases. Fourth normal form, 4NF. 4NF deals with multi-value dependencies, where a non-key attribute is dependent on a combination of attributes that are not the primary key. By eliminating multi-value dependencies, 4NF further reduces the data redundancy and improves the data consistency. Achieving 4NF may involve splitting a table into multiple tables to adhere the normalization rules. Fifth normal form, 5NF. 5NF, also known as Project Join Normal Form, PJONF, addresses joint dependencies in a database. A joint dependencies occurs when a data is retrieved by joining multiple tables, leading to the potential data anomalies. By reconstructing the database to eliminate joint dependencies, 5NF improves data integrity and query performances. Domain key normal form, DKNF. DKNF is the highest level of normalization and combines the principles of BCNF and 5NF. In DKNF, every constraint is a logical consequence of a definition of keys and domains. Achieving DKNF ensures that the database is free from all types of anomalies and redundancies. Considerations for normalization. While normalization is essential for databases design, it is important to strike a balance between normalization and performance. Over-normalization can lead to complex queries and potentially impact query performances. It is crucial to consider that a specific requirement of an application and a trade-offs between normalization and performance. Denormalization. Denormalization is the process of intentionally adding redundancy to the database for performance reasons. In some cases, denormalization can improve query performance by reducing the number of joins required. Denormalization should be approached consciously to avoid data inconsistencies and maintain data integrity. Examples of normalization. Consider a database for a library where books and authors are stored in a separate tables to avoid data duplications. In an e-commerce database, customers' information is stored in separate table linked to order to prevent redundant customer data in each other. Normalization can also be applied to employee databases, where employee details are stored in separate table linked to departments of better organization. Challenges for normalization. Normalization can sometimes result in complex databases schemas that are difficult to understand and maintain. Modifying a highly normalized database structures may require more effort and careful planning. It is important to strike a balance between normalization and practicality to ensure the database meets the needs of application. Tools for normalization. There are various tools and software available that assist in normalizing a database schema. SQL design tools like ERWin, Toad Data Model, and SQL Power Architect offer the features to help with normalization. These tools provide visual representation of database schema and support the implementation of normalization rules. Normalization best practices. Start with identifying the functional dependencies in a data to determine the appropriate level of normalization. Break down complex tables into simpler and smaller, more manageable tables to adhere to normalization rules. Regularly review and refine the database schema to ensure it remains normalized and optimized for performance. Common mistakes in normalization. Failing to identify all the functional dependencies in a data can lead to incomplete normalization. Overlooking the needs of denormalization in certain scenarios can impact query performance. It is essential to thoroughly understand the normalization rules and apply them correctly to avoid common pitfalls. Case studies on normalization. Explore real world examples of how normalization can be applied in different industries to improve database performances and data integrity. Case studies can provide insights into the challenges and benefits for a normalization in practical scenarios. Analyze how normalization strategies have been tailored for specific business requirements and impact on overall system performance. Future trends in normalization. With an advent of big data and no SQL databases, the traditional normalization techniques are being re-evaluated. New approaches to data modeling and schema design are emerging to address the scalability and flexibility requirements of modern applications. The future of normalization in SQL may involve a blend of traditional normalization principles with innovative techniques to meet the evolving needs of data management. Let us conclude. Normalization is a fundamental concept in a SQL database design that aims to reduce the data redundancy and improve the data integrity. By following the principles of normalization, database administrators can create efficient, consistent, and maintainable database schemas. Understanding the different levels of normalization and applying them in appropriately is crucial for designing robust and scalable databases. This is all about the normal forms in SQL. Thank you.